This is Geometry, Chapter 3, Section 1, in which we will be studying parallel lines and transversals. When we're dealing with coplanar lines, lines that are in the same plane, that don't intersect, what you have is called parallel lines. It's a term you already knew. You knew parallel lines didn't intersect. The only thing we're adding to that is the idea that it's coplanar. There's another type of line that doesn't intersect, or another type of lines, plural, that don't intersect. These are not in the same plane. And when they're not in the same plane, we call them skew lines. And then along the similar idea, planes that don't intersect are parallel planes. There's no such thing as skew planes. Either they're parallel or they're intersecting. So we need to look at the idea, the difference in the idea between being parallel lines and being skew lines. Parallel segments, we said, are in the same plane. So for example, HQ and PE would be parallel segments. Parallel lines, parallel segments, same idea. Similarly, PR would be parallel with EG. And those aren't the only two in this picture. There's several, there's many others. RF with GS, for example, would also be parallel because they're in the same plane. Now compare that with skew segments, segments that are not in the same plane but still don't intersect. Something like FR and PE. FR is in the bottom of the box running from front to back. PE is on the top of the box running from left to right. They're not in the same plane, they're going entirely different directions. Similarly, EG and HP. Now again, those aren't the only skew segments that we have in this diagram. It's just, it asks for two pairs, I picked two pairs. There's lots of other choices. Now we'll get to transversals here. The idea of a transversal is what we have is a line that meets two or more coplanar lines at two different points. In our diagram here, line P is a transversal. It intersects Q at one point right here. It intersects R at an entirely different point. P runs between Q and R. Now, if I were to move line R up to here, then that would not be a transversal. P wouldn't, because it intersects both of them at the same place. They have to meet in two different places to be a transversal. Now, hopefully you can see on our diagram that when you have a transversal intersecting two lines, you get 8 different angles. 1, 2, 3, 4, 5, 6, 7, and 8. Okay. One of the things we're going to be doing a lot with this chapter is classifying these angles. So we're going to start the idea of classifying angles here. Angles 1, 2, 7, and 8 are all in between lines Q and line Q and line R. They're in the inside space between the two lines. We call that interior angles. 3, 4, 5, and 6, on the other hand, are outside the two lines. So they would be, I know, surprising, exterior angles. Now, once we get the idea of interior and exterior figured out, which I think you've already got, because you're smart people, we can subdivide those things. Angle 1 and angle 7, they're both interior angles, and they're on opposite sides of our transversal. Angle 1 is on the left, angle 7 is on the right. When you're in that condition, opposite sides of the transversal and both on the inside, they call that alternate interior angles. They alternate sides of the transversal, and they're between the two lines. I'm pretty sure you can guess what 3 and 5 would be called. They're on opposite sides of the transversal, one on the left, one on the right, and they're outside those lines. So that's going to be alternate exterior angles. 2 and 7 are on the same side of the transversal. They're both on the right, and they're both inside. Your book uses the term consecutive interior. Some books that you may run into down the road will use the term same side interior. Okay. And similarly here, 3 and 6, they're both on the same side, and they're both outside the two lines. So that would be consecutive exterior. Again, you may hear same side exterior, depending on the book you're using. And then our final group of angles that we need to talk about, or classification, angle 3 and angle 8. Notice where these two angles are. They're both above the line. One is exterior, one is interior. They're both on the same side of the transversal. If you want to think of it this way, they're both in the upper left of each intersection. When they're in the same place in each intersection, we have a term we use called corresponding angles. They correspond to each other. They're in the same place. 2 and 5 would also be corresponding, because 2 is in the bottom right of its intersection. 5 is in the bottom right of its intersection. So that's corresponding angles when they're in the same basic place. So they're going to ask us to identify where the transversal is for the given angles, and to classify the relationship. So we're going to have to decide if they're interiors, exteriors, consecutive, alternate, corresponding. What are they? First off, they gave us angle 2 and angle 3. Angle 2 is here, angle 3 is here. To find the transversal, we need to find the line that these two have in common. Angle 2 is on line P and line Q. Angle 3 is on line N and line Q. So the transversal has to be line Q. Now that we've identified the transversal, we can decide what kind they are. They are on the inside of the two lines the transversal intersects, and they're on opposite sides, so they would be alternate interior angles. Okay. Consider angle 5 and angle 10. Angle 5 is on line N and line M. Angle 10 is on line N and line Q. Which line do they have in common? They have line N. So line N is our transversal. Now we have to decide on the relationship between them. 5 and 10 here, they're both on the right-hand side of the transversal. One is an interior angle, one is an exterior angle. They're both in, if you will, the upper right part of the intersection. So that makes them corresponding angles for that transversal. Okay. So what have we looked at today? We've looked at what it means to be parallel. We've looked at what it means to be skew. We talked about the difference between those. The key thing is, are they in the same plane or not? We also looked at alternate interiors, alternate exteriors, consecutive interior, consecutive exterior, corresponding. That all depends on where the angles are in relationship to the transversal, the line that goes between the two lines in question. Hopefully, as always, if you had questions along the way, you jotted those down, bring those in with you, and we will see you in class.